Hello, in this talk we're going to talk about the file systems that are available in Windows 10. Let's get started. So what exactly is a file system? Well, a file system's primary job is to organize the records or to come up with a system in which to store data. Again, I'm going to keep focusing on platters instead of solid state, but in any form of storage, right? In this case I have a platter. We're going to have sectors, right? These sectors are very small, tiny areas of, in this case, the platter, where we can change the magnetic properties. And what a file system is going to do is organize it into clusters. Okay. Now, the interesting thing about clusters is there's positive and negative sides to having them big or small. All right. The smaller a cluster, the bigger your database is going to be, two-dimensional database, but you're going to have this giant database listing all the possible locations of all the files, right? In the case of FAT, it's a file allocation table, right? So this table is going to contain all the locations and which clusters, and by the way, it can be spread up into multiple clusters, right? You can have a file that's taking up this part of the cluster, eats up this whole thing, right? And then you have the second part of the file eats up part of this cluster, okay? So anyway, it has a giant database of all the locations of the files and which clusters they're located in. The bigger this database, though, the more memory it's going to take up, more processing power in order to figure out where things are located. So again, you don't want too many clusters. You can't make it's not a good idea to have a cluster as small as like a single sector, or even a couple, 2, 3 sectors. And by the way, this is where FAT32, FAT16 gets its number from. Okay. The downside of having really big clusters, however, is a file is going to take up one cluster. So if you have a tiny little file, the rest of that cluster is all going to be wasted space. So again, you're looking for a Goldilocks solution, something not too big, not too small. The other big thing is, if you notice, like FAT16, FAT32, which we're going to talk about, FAT32 can support much bigger drives, and part of that is because it has a bigger cluster, and more space is allocated for the actual table, so that allows it to be bigger. All right. Anyway, let's talk about. So again, recording where this information is. Now remember, there are thousands of move, adds, deletes going on. Okay. In your operating system, even when you're not doing anything. Okay, it's complicated. Speed is critical, and accuracy is critical. Right? We kind of don't like it when our operating system just loses files on us. Matter of fact, usually if files are lost, it's very much chances are it's the user's mistake. But so there's all these little reads going on, and moves and adds. An important concept too on a move and a delete. So when your file is recorded, right, your file is eating up this cluster here, it's eating up this cluster. We're going to try to organize in a track, which we've talked about before, right? So it's going to eat up these couple clusters. That needs to get recorded in this database. Now its actual location on the hard drive, as far as for stupid humans, let's put it on the C drive, for example, right? The C drive, and we'll just put it under users directly. That area, this is just a property of that file, right? It doesn't really matter what, the drive does. The C drive, the fact that it's on a specific drive, that matters. But the actual file or the folder location doesn't matter at all. It doesn't dictate what part of the hard drive that data is stored on. So you move a file from like C users over to C users and then CIT admin 120 and documents folder, and you move that. There's no actual moving of the file. This data doesn't get changed on the hard drive. All they do is they change the property of that location in the file. Okay, and likewise, when you delete the file, this just gets deleted. Okay, when that gets deleted, you have orphaned files on the hard drive. Okay, until you write over those files are still recoverable. If you take software, it can go through and look for orphaned files. and come up with a big list, because those files still exist there. Okay, you can download utilities to zero files instead of the clusters that were used to save a file. You can have them zeroed out around 7 times if you want to be really thorough, because you can see ghost signatures. Well, with very special equipment, very expensive and special equipment. So anyway, long story short, when you delete a file or move a file, all you're doing is changing the property of that file. Okay. I just had a student ask me, well, what happens if I have things in my documents? My documents, just think about it as a another folder. Okay, when you delete things and they put it in, did I say my documents? I meant in the recycle bin. When things get moved to the recycle bin, it's just like a special file folder with some extra properties that allow it to files can get moved there automatically if you delete them, and until you clear them out of there. Then when you clear them out of there, it deletes the record pointing to it. So it's almost like a move. If you copy data, it's going to have to get copied over. So again, if you copy it, then we're going to have to go find 2 more clusters, ideally next to each other for reading and writing purposes, and then we would copy that data over. Okay, that is why a copy takes longer than a move. If you're just moving something, I'm just changing a little bit of data, changing the location in the where it's recorded. If I'm copying it, then I'm actually recreating that data in a different part of the drive. All right, so we have multiple file systems, and let's go through them, shall we? So so an old file system that's still around and used quite a bit in Windows is FAT, which stands for File Allocation Table. All right, File Allocation table is, did that just disappear on me? Sure. File allocation table was supported with MS-DOS. It came along with MS-DOS. It was used in Windows all the way up until Windows ME, before they switched over to the NT kernel. Anything built on top of the MS-DOS kernel needed to run FAT. Okay, DOS did not work with NTFS. So Windows XP and Windows 2000, depending on how you look, and NT4, NT3.0, all at NTFS. We'll talk about that. So FAT FAT16, or just sometimes called FAT, so it can either call it be FAT16 or FAT, can support up to 4 gigabytes of RAM. Sorry, gigabytes of RAM. Sorry, that's capital B. It can support up to 4 gigabytes of RAM. FAT32 can support up to 32 gigabytes of RAM. And exFAT, which is the newest version of FAT, short for extended FAT, can support up to 128 petabytes. The whole reason why exFAT came out, and it can support bigger files than about a gig. FAT32 can't support files that are bigger than somewhere around a gigabyte. exFAT can support larger files. exFAT came out essentially because FAT32 is still around in the wild. All right, it's used in the case of universal access. Not recommended for your operating system. Now, so the big problem, one of the huge problems with FAT is there's no access control in the file system. So we're going to talk about this with NTFS, but NTFS, you can actually control what users can control every single file and folder on the entire hard drive. Every single file and folder on the entire hard drive can be, you can specify who can touch and who can read it, who can modify it, who can change the control property, the access list. That's all supported with NTFS. With FAT, there's none of that. There's going to be a couple attributes, these things left over called attributes, which we'll talk about, which are not really useful at all for security purposes. So it's not secure at all. But that's partially why it's still around. If you think about it, thumb drives. If I have a thumb drive and I want to share data on my thumb drive with you, I don't want you to have to set up a user on your desktop, or I don't want to have to set up your user on my desktop. Therefore, I can put it on the files on the thumb drive if it was NTFS, so I should bring it over there. FAT, because it doesn't have users, makes a perfect file system for sharing files via thumb drives or external hard drives, although a lot of external hard drives can be NTFS. If you're going to back up your important data, it's a good idea for security purposes. So anyway, FAT is around for thumb drives. That's the main reason why we had extended FAT come out. Extended FAT supports up to 128 petabytes. All right. Again, not recommended for your operating system, the hard drive of your system, but it is recommended for like thumb drives. All right. What is recommended is NTFS. NTFS has well, we'll go through the checklist right now. Has log and checkpoint consistency checks. It is much more robust as far as being able to do any kind of forensics on. So after the fact, if you're looking through the logs, looking for past activities on a system, you would much prefer to have an NTFS system. That way you can check you can check the logs and try to figure out when files were modified, deleted, moved, that kind of thing. Also, checkpoint consistency checks is going to check for consistency of data. Has automatic bad cluster management. So if a cluster goes down, the magnetic properties cannot be changed on a part of a platter. In the case of a solid-state hard drive, if part of the solid-state hard drive can no longer record data, it will automatically keep a file of those bad areas. All right. Has transactional NTFS. What it does is it verifies any writes it does to the disk. So it makes sure it did write the data that it was supposed to write, and it wrote it correctly. So it does verification. All that kind of indicates where it's coming from. NTFS was meant as a server's file system, right? You see all these consistency checks and redundant systems to check for to verify the accuracy of data. So that's NTFS was a file. It was for servers originally designed. File names are stored in Unicode. So another downside to FAT is it was stuck to the 8.3 format, which meant the file names could only be 8 characters long with a dot and then 3 letters for the file extension. Here in NTFS, that you can be a lot more creative with file names. However, that being said, / question mark, less than, greater than, backslash, colon, asterisk, pipe, and quotation marks, double quotation marks. Any character you need to hold the control key is illegal. Okay, for file names. All right. So you will have to know that, by the way. Memorize that. Just these characters. These are all characters are used in file systems. Like backslash is used for directory reference. Colon is used for drive reference. Asterisk is used for filter. So quotes are used to pass a string. So anyway, a long story short, all these are very special characters, and therefore they cannot be used in file names. And then anything with a control key is illegal as well. But these are the characters you're going to have to memorize. Alternate data streams, multiple programs or systems, not users, can have multiple data streams to the file system. So again, the file system trying to be as quick and efficient as possible. We're going to limit the user to one thing at a time. And however, the operating system and systems, background systems can have multiple data streams running to the file system. Disk quotas, if you have a disk quota system, again, this is big on servers. What you do with disk quota is they're essentially designating how much space one user can possibly use on the hard drive. It needs to be enabled, turned on. By default, it's not turned on. And it's going to use ownership. We'll talk about that in a couple seconds, what ownership looks like. But files have to be owned by a specific user. Okay, most system files are going to be owned by system. Most files under your profiles, which we haven't talked about yet, but your user profiles, files created by your user, is going to be owned by that user. All right, so uses the owner to track which user is using the space. All right. We have the encrypted file system, which is built into NTFS that allows you to encrypt files. That's something you'll do during your lab, and you'll export a key. It's going to use symmetric encryption, so it uses the same key to encrypt and decrypt when it reads and writes to these files that are in the encrypted section of the hard drive. If you want another operating system to read that file, you need to pass the key off, so you can do that by exporting it and then using an asymmetric key, which uses a different key to read and to encrypt and decrypt to encrypt the file, and then that way you can send that along and the asymmetric key to decrypt it. It uses volume mount points, which you can use from the disk management MMC. You can have a folder secretly point to another volume. So it looks like a normal volume to the user, so just maybe something under My Documents, but is actually redirecting to another volume, which is good for backup purposes, or making it seem like the user there's not a big thing going on when in actuality you're kind of moving it to another volume. All right. File and folder permissions. Much more on this later. We're going to talk about this when we talk about authentication and authorization, particularly authorization. But this is the primary building block for security in NTFS, in Windows 10. Okay. Yes, we have a firewall. Yes, we have anti-malware, and we have all these different things. But the very fact that we can put on every single file and folder a access control list means that we can have very granular control of what users can and can't do on the operating system. Okay, it's very important. And FAT did not have it, so reason why FAT had to go. Compression built into the file system. We have compression now, so you can compress files and zip them up into a .zip file. Before Windows XP, you had to do that via a third-party app. Shrinkable, extendable partitions. If you're caught up on your labs, then you've already done this. With an NTFS partition, you can shrink a volume. All right, and you can expand it too. Extend it. Excuse me. Volume mount points. Mount points. We already talked about. It's up there twice for some reason. And we have symbolic links. A symbolic link can use a UNC path to link to a exe. So right away, I guess I should create a link. I think would make sense. So if I can get to a exe, let's see if I can do PowerShell. Running a little slow at the moment. Come on. Thank you. I'll go to properties here, and this itself is a shortcut. Okay, so this icon down here is a shortcut. It took me a little while to get to the properties, and I apologize for that. So I have a shortcut key going to it. If I Control-Alt-P, it will open it up. But what happens is essentially here's the target: system root, which is a variable, system32. Right, Windows PowerShell 1.0 PowerShell exe. So this file, which is a .llc, I'll go here, or shortcut.lnk, it's a shortcut file, right? Actually points to this location right here, to this exe. Okay, it will pass along some variables. Like in this case, it's going to pass along a home drive and home path variables when it opens up, so you can do that as well. But this is a shortcut link, right? It's a file that points to another file on the hard drive. All right, going back to the security, I was going to show you on our M drive, we have an encrypted folder. All right, I'm going to do properties, and we're going to look at security. Well, we haven't talked about attributes just yet, but so we'll wait on that. If I click on security, you can actually see users are allowed to read, list the contents, and read. That's all users are allowed to do. However, administrators can change. As a matter of fact, full control means I can actually go in and edit these properties. If I click edit, I can go through and let users write to it now. So I'll let them modify. Right? I'm not going to do that, but I'm just saying I could. Again, this is a very powerful tool. If I click on advanced, I'll actually see who the owner is. In this case, it's CIT120 admin because they created it. In the lab, you'll be creating this. Then that goes into that would count towards CIT 120 admins quota if we had a quota on this computer, which we do not have. All right, let's get back to the presentation, and we'll get back to there for more things. So we have some other file systems. We have REFS, which is essentially a version of NTFS. It loses a couple things. You can't. There's no compression or encryption. However, it will. It is more resilient. Well, that's hence the name. It's essentially a more. It has even more consistency checks. It checks for more aggressively, checks for bad clusters and for performance and consistency to make sure it doesn't lose data. It's built for servers primarily. Okay, you're not allowed to put it in a boot volume. Has some features removed, but Windows 10 can read from it. We have another file format, UDF, Universal Disk Format, made for so multiple file systems can read and write. We use it for CD-ROMs and DVDs. All right, so let's talk about attributes. Going back to the FAT32 days, we did have attributes we could use in files. And what I'm going to do is I'm going to create a file in here. We'll create a new notepad, or new text document. We'll call it test because we're playing. And let me go into, well, I'll add some data just to give it some data. So if I double click on it, I put a little bit of data in here. We'll save it. Alright, so right now it's eating 1 kilobyte according to that. If I go into properties, it's actually going to show it's eating up 6 bytes actually. But on the disk it's eating up 4 kilobytes. There's a couple reasons for that. Number one, it's again eating up an entire cluster, so it's eating up more space than it actually has. And second of all, it's mirrored. So it's eating up 2 clusters, one on one drive and one on the other. That's why we have size on the disk, and it's so much different than the actual size. Okay. Now we have these 2 attributes down here, read only. If I click on read only, right, what I'm doing is I'm saying you can read it, but I can't write, I can't save to it. So if I try to put more data in, I do file save. I'm going to get a little message saying, hey, what do you want to save it as? And I'll say, well, I want to save it as test. Do I want to replace it? Yes. And then finally, I'll get an error telling me it's not allowed. Right? Set to read only. Now again, it tells you it's read only, and any user, right? It doesn't matter who. Any user, all they have to do is right-click on this, go to Properties, and not select read only, and then they can save to it. All right. So in no way, shape, or form is this any type of decent security. Okay. We also have hidden. Again, I can make it hidden. Whoops, it's not hidden. Why? Because I have view hidden files turned on. So we'll turn that off, and all of a sudden it'll disappear. All right, but if I go back to view, say hidden items, it will show back up. All right. So again, not really legitimate security in any way, shape, or form. Okay. These are leftover attributes back in the DOS days. They were seemingly powerful back in the DOS days, but they were never that powerful. All right. So we talked about read only. We talked about let's talk about the advanced properties as well. So if I alt tab back over, I go to properties, and I go to advanced. Well, we'll not make it read only. I think the folder is read only, so let's try to make it sure. All right. So if I click on advanced, I have the archive bit right here. What this bit means essentially is when the bit is turned on. Do I have it for the entire folder, or do I have it for file? I thought I had the file. I don't think I had the file. There you go. All right. So, but if I have the go to general, so the file is ready for archiving. In other words, the bit is turned on. It means it hasn't been backed up, right? If I run backup software or I run use other backup server and it gets backed up, it will uncheck that bit. I can also manually uncheck it, but that's the whole point. Is just a little light switch to toggle whether or not a file has been backed up or not. We can also tell it whether or not to be indexed. Indexing, essentially Windows can create a giant directory of all the files and locations on its hard drive, including content. So if I really wanted to search for this text file using that content, the HGs and Ks, or HGs and Js, I put in there, no Ks. I can search on that. Okay, so because it's indexed, right? So if I had a file that I use a particular word a lot, I can search for it if it's been indexed. Okay. By default, a lot of files and folders in your users folder is going to be this is going to be selected. So just FYI. And again, I can compress or I can encrypt. So if I compress it, it is encrypted right now because it's in this folder called encrypted. I think my backup drive is actually set to do compression. So if I go back up to this PC and I go back to the M drive and I go to backups, I think everything in here by default, I'll do another file folder called, it's rich text now, test. And I think, yep, by default it's compressed, right? And that's because this folder is compressed. That's what that little symbol indicates up there. All right, so those are also on the advanced tab. In the command line, you can use the command attrib to get the attributes that File Explorer can't. Sometimes REFS attributes. You use compact to compress a file and cipher to encrypt it. Just to let you know, you can also change. When I say get to attributes, you can change. You can not only can you read attributes of a file, you can change them. Again, if you're writing scripts with PowerShell, that's handy to know. Another important concept is, and this follows up on what I was saying earlier, if you move a file, okay, again, if you're moving a file, so I have my file location, right, it's in a couple of clusters, let's just say, we'll pick out a couple clusters here, all right, so I have my couple of clusters, there's data in here, right, when I move it, right, I sit there and say, hey, I want to move this to a different file location in the same volume. If it's in the same volume, it doesn't actually move it physically on the platter, right? What it's going to do is it's going to just change the property of its location. That's supposed to be a circle, sorry. It's going to change the location of the property in the file, right? And it's going to sit there and say, okay, this is now located in this other location the user wants it in, okay? Therefore, it doesn't create anything new. It doesn't modify this file. So what's going to do, it's just going to keep the same attributes. The attributes stay the same. In any other scenario, so if I copy these within the same volume, I'm creating that file again. I have to recreate, it's a clone. And by the way, that's why a copy takes a lot longer than a move. I have to take this data and copy it over here. So if I'm copying, I'm creating a new one. If I'm creating a new one, what I do is I grab the attributes of the parent folder. I look at what the parent folder has for attributes. I will take that as my attributes. Okay, so if it's hidden, the file that I just copied over will be hidden. All right. If I copy or move to another volume, so I have a completely different volume over here, right? A different disk, and I want to copy it. I want to either copy it or move it. I'm going to have to make a copy. Even if I move it, what I'm doing is I'm making a copy of that file, sending it over, right, and make that copy, right, because it's on a different volume. So I can't just change the properties to indicate a different location because that location is on a different disk. It needs to be moved over to that disk. So what I do is I copy it over first, then I delete the original. Okay, and because I'm creating a new file, and if I copy it, obviously I need to copy a new file. Anytime I create a new file, what I'm going to do is look at the parent folder for their attributes and then copy those over to mine. All right, so letting you know why it was, let me give you the bare bones. Okay, so if you move if you're moving a file within the same volume, it keeps its attributes. If you copy a file within the same value, copy a file to a different volume, or move a file to a different volume, it's going to take the attributes of its parent folder. All right, that's the simplest way to put it. I just want to let you know why it does what it does. All right, so we have this new thing called storage spaces in Windows 10. It's predominantly used in the world of servers, but what you can do is you can make pools. So you can take different disks of different sizes and put them in these pools. And once you collect these pools, then you can assign pools dynamically, so not all the pool, part of the pool, over to these storage spaces. And then the user is only going to see this one storage space. So it's really beneficial to a server manager. In the case of a desktop operating system, you probably wouldn't use it. You'd have to have a very special circumstance to use it. Database or rendering or working on large video editing, working on large files. But again, you cannot use the system drive as a storage space. So you can, so you're going to take, again, move volumes into pools and then pools into spaces. All right. When you add a disk to the storage space, it must be at least 4 gigabytes. All data will be overwritten on the disk. You can create, delete, reassign pools to spaces and volumes in the utility, which is located under System and Security Storage Spaces. Virtual hard disk. We're going to be playing with virtual hard disk. A virtual hard disk essentially is a file that's on the system. Then that gets mounted as a whole new volume with a drive letter and everything. Okay. In our lab, we were creating the V drive. So if I go back to this PC, let's see if it's here. We don't have it. So I think it was. So I think I took that out of the lab, actually, now that I think about it, to save on time. So anyway, if you have a virtual hard disk, that virtual hard disk is essentially a file that you can then mount and it'll become a drive letter. Okay. Now the file can either have a .vhd or a .vhdx file format. Just know that the VHD is older. VHD, again, anything in Microsoft, if it ends in an X, means essentially they've updated it and it's now formatted in XML format. The nuts and bolts here is the VHD can only support up to 2 terabytes, while VHDX now can support up to 64 terabytes. So in the size, you can either make it dynamically expanding or fixed. If you fixed, you essentially, so let's say we're creating a terabyte drive. Okay, so if I say it's fixed, when it creates that file, it's going to be an empty 1 terabyte file. So I'm already taking the space. Okay. If I do a dynamically expanding, what I do is I say, hey, max size is 1 terabyte, but right now just start off at just a few bytes and then make it get bigger as I need it, right? But you're still capping off at a terabyte max. All right, so that's dynamically expanding or fixed. To attach or detach a VHD, you just simply double click on the file, or if you want more control, you can go to PowerShell and type mount-VHD, or you can do it in diskpart, or you can go to diskmanagement.mmc, again, to point to that file and mount it as a volume. All right, that's everything we wanted to cover today, and I'll talk to you later.